Hello everyone, and in this video we are going to discuss how to get the limits of function using the analytic approach. Whereas for this discussion, our objectives are: number one, to illustrate the limit laws and apply the limit laws in evaluating the limit of algebraic functions such as polynomial, rational, and radical functions. But before this, I want you to think and answer this question. So what are laws and why are they created? So you may pause this video and share or ponder what are the importance of laws and why are they created. So for sure, there are a lot of things that you can think about the importance and the uses of laws. But just to have a general idea about this, laws are created for us to follow for greater good. Okay, what will happen if is no rule on a society or in a place? But there will be chaos. So to keep order and peace on a society, it is important for us to have laws, where we can follow them. The same also in getting the limits of function, because later on we will be using them so that we can easily get the limits of functions without using the table of values and the graphs. So that is actually the main purpose of our limit laws. They are used as alternative ways in solving the limit of function without using the table of values and graph. Okay, what have you noticed before when we solve for the limit of functions using the table of values? But it's time consuming, right? So for this discussion, we'll find out the easiest way to get the limit of function without using the table of values and their graph. Let me go over our limit laws quickly now, since all of these are already found in Canvas. Now, if you browse through our Canvas module. So for our limit laws, we have 9 basic limit laws. So our first law is the limit of a constant is itself. So if you are having this expression or equation, the limit of k as x approaches to c is equal to k, meaning the limit of a constant is the constant itself. So for example, our k here is 5. Therefore, the limit of 5 as x approaches to c is also equal to 5. Next, second law, the limit of x as x approaches to c is equal to c. The simple explanation, no? The limit of x as x approaches to c is c. So it's like substituting whatever value x is approaching to our function. Next, for the remaining theorems, we will assume that the limits of f and g both exist as x approaches to c, and that they are L and M respectively. So in other words, the limit of f of x as x approaches to c is L, and the limit of g of x as x approaches to c is M. So for our third law, the constant multiple theorem, the limit of a constant k times a function is equal to the product of that constant and its function's limit. So for example, we have this equation: the limit of k times f of x as x approaches to c is equal to k times the limit of f of x as x approaches to c. So meaning to say, you just get, or you just multiply k with the limit of f of x. So that's k times L. And for the other remaining theorems, actually they are operational limit theorems lang, no? So we'll go through them one by one. So for the addition theorem, the limit of a sum of functions is the sum of the limits of the individual functions. So meaning to say, if you have two terms or two functions and you want to get their limit, it's like getting the limits of each term. So you get the limit of f of x plus the limit of g of x. Now, therefore, the answer here is L plus M. The same also for subtraction theorem, Where for this case, the limit of a difference of functions is the difference of the limits of the individual functions. So it's like getting the difference of the limits for each term. Next, for the multiplication theorem, the same also with our previous operations, but this time our operation is multiplication. So you just multiply the limits for each term. The same also for the division theorem, but for this case, in getting the limit of a quotient of functions, you need to make sure that the denominator of your function is not equal to 0. Because if your denominator is equal to 0, then it will result to an undefined answer. It's undefined, meaning your answer might have, or the limit for your function might not exist. Next, for the power theorem, it's like raising the limit of your function with an exponent. The limit of an integer power p of a function is just that power of the limit of the function. So the limit of f of x raised to p as x approaches to c is equal to L raised to p. And lastly, the radical or root theorem. If the nth root, if n is a positive integer, the limit of the nth root of a function is just the nth root of the limit of the function, provided that the nth root of the limit is a real number. We need to say it's like getting the limit of the nth root of the function. So the limit of the nth root of f of x as x approaches to c is the nth root of the limit, or the nth root of the limit of the function. So let us have this example so that we can test if you have fully understood our limit theorems or limit laws. So assume the following. We have the limit of f of x is equal to 3, the limit of g of x is equal to -2, and the limit of h of x is equal to 1. So compute the following limits, starting with letter A. The limit of 3 times g of x plus 5 times h of x as x approaches to c. So what we need to do here is we just substitute our given values or our limits on each term. So we will have 3 times -2, since that's the limit of g of x, plus 5 times 1, which is the limit of h of x. So performing the operation, we'll have 3 times -2 is equal to -6, plus 5 times 1 is equal to 5. Therefore, the answer for this in letter A is -1. Next, for letter B, we are asked to get the limit of f of x minus g of x minus h of x as x approaches to c. So again, similar with what we did in letter A, we'll just substitute our limits for each term or for each function. So we'll have 3 for the limit of f of x minus -2 for the limit of g of x minus 1 from the limit of h of x. So simplifying this, we'll have 3 plus 2 minus 1, and the result will be +4. And last, the limit of h of x raised to 5 as x approaches to c. So with this, we'll just substitute h of x or the limit of h of x to this function. Therefore, we'll now have 1 raised to 5, and that will be equal to 1. So let's generalize what we did here in our perception check. What mathematical method did we use in order to get the limits of our function? So if you are thinking the substitution method, then you are correct. So meaning to say, in getting the limits of functions, it's like substituting your given value where your x is approaching to your function so that we can define the limit. So for functions composed of additions, subtractions, multiplications, divisions, powers, and roots, limit may be evaluated by direct substitution provided that the resulting expression is defined. So for example, we have this. The limit of 3x squared minus 5x plus 4 as x approaches to 2. So in order to get the limit for this function, we'll just substitute 2 to our function. Easy as that. It's like what we did sa Gen Math, evaluating functions. So we'll just substitute 2 to all the x's of our function. So we'll have 3 times 2 raised to 2 minus 5 times 2 plus 4. To simplifying this, we'll now have 3 times 4 minus 10 plus 4 results to 12 minus 10 plus 4. And the answer would be positive 6. So again, it's just like substituting where your x value is approaching to your function. This time, try it yourself. This time, let us try to evaluate the following functions using the substitution method. So you may pause this video and try solving this first, then after which we will present the answers. I-pause na. Okay, sige, let's check. So for number 1, we are asked to get the limit of 3x squared plus 5x minus 1 raised to 5 as x approaches to 1. So what we will do is we substitute 1 to all the x's in our function. So we'll have 3 times 1 squared plus 5 times 1 minus 1 raised to 5. Simplifying the functions, we'll have 7 raised to 5, and that would be equal to 16,807. Did you get the same answer? Very good. How about for number 2? We are asked to get the limit of 3x squared plus 5x minus 1 times the square root of 5x plus 4 as x approaches to 1. So similar with what we did in number 1, we'll just substitute 1 to all the x's in our function. So we will have this substitute 1 to all the x's, then simplify. So we'll have 1 squared is equal to 1 times 3. It's 3 plus 5 minus 1. So that would be equal to 7 times 5 times 1 is equal to 5 plus 4 is equal to 9. So we'll have the square root of 9. So we'll now have 7 times what's the square root of 9? It's 3. Therefore, 7 times 3 is equal to 21. Same answers. Very good. Next, for number 3, we are asked to get the limit of x squared minus 1 over x minus 1 as x approaches to 1. And obviously, if we do the direct substitution, we arrive with an indeterminate answer. Meaning to say there are other processes for us to get the limit for this function. So to get the limit of this function, what process can we do? So if you thought of factoring and simplifying, then you are correct. Now we can factor out our numerator first, canceling terms that are common on both numerators and denominators, and proceed with the substitution method. So if we are to factor out x squared minus 1 over x minus 1, we will have the factors of the numerator, which are x minus 1 times x plus 1. And canceling out the common term, what's left? We have the limit of x plus 1 as x approaches to 1. And with this, we can now proceed with our direct substitution method. So we'll have 1 plus 1 is equal to 2. So the second method in getting the limit of a function is the factoring method, in which functions are factored or simplified first before substituting the value to where x is approaching to. So for example, we have the limit of x squared minus 6x plus 9 over x squared minus 9 as x approaches to 3. And for this function, obviously, we need to cancel out first common terms so that we can proceed with the direct substitution method. So the factors of both numerators of the numerator are x minus 3 times x minus 3. And for the denominator, our factors are x plus 3 times x minus 3. And with this, we can now cancel out terms that can be canceled, that are common in both numerators and denominators. So we'll cancel out x minus 3. And what's left? We'll have the limit of x minus 3 over x plus 3 as x approaches 3. And with this, we can now proceed with the direct substitution method by substituting 3 to all the x's of our function. And our answer should be 0 over 6, and that will be equal to 0. Now this time, I want you to try on your own to factor out or to evaluate the limits of the following functions using the factoring method. So you may pause this video, and afterwards we will check or present the answers for each item. Okay, let's check. So in number 1, you're asked to get the limit of x minus 3 over x squared minus x minus 6 as x approaches to 3. So obviously, if we do the direct substitution method, we will arrive with an undefined or with an indeterminate answer. Meaning to say, we should do another way so that we can get the limits for this function. And that is through factoring the denominator, correct? So the factors of our denominators are x minus 3 times x plus 2. And with this, we can now cancel out terms that can be canceled, that are common in both numerators and denominators. And what's left? We have the limit of 1 over x plus 2 as x approaches to 3. And with this, we can now proceed with the direct substitution method by simply substituting 3 to all the x's of our function. So the answer should be 1 over 3 plus 2, and that would result to 1 over 5. How about in number 2? For number 2, we are asked to get the limit of x plus 5 over x squared minus 10x plus 5 as x approaches to 5. Since the denominator can be cancelled, we can do it first, so that we can check if there are terms that can be cancelled out. So the factors of our denominators are x minus 5 times x minus 5. And with this, there are no terms that can be cancelled. Meaning to say, we can just proceed with the direct substitution method. And by doing so, we'll have 5 plus 5 over 5 minus 5 times 5 minus 5 is equal to 10 over 0, which is undefined. Therefore, the limit of our function in number 2 as x approaches to 5 is equal to DNE, or the answer is undefined, meaning to say the limit does not exist. Yeah. So take note, if the answer after finding the limits using these methods are undefined, the limit does not exist. This time, I want you to try on your own by solving this, evaluating these limits on your own, and please send your answers through Canvas inbox. Okay, so this will serve as your assignment. And the solution for this assignment will be discussed in the next video. If you have questions or clarifications, my online students, kindly message me through Canvas inbox. And again, do not forget to submit to me your assignment through Canvas inbox. Thank you, and have a blessed day, everyone. Bye.